Good morning, students. In this video, I will explain the electric field intensity at a point on the axial line of an electric dipole. This derivation is very important because this derivation will be asked for 5 marks in your examination. So by learning this, you can easily score 5 marks. Now let us go for the derivation. First, let us consider a dipole with charges minus q and plus q separated by a distance 2a, and O is the midpoint of the dipole. Now you can observe in the diagram, this is a negative charge and this is a positive charge. So negative charge is placed at A and positive charge is placed at B. The distance between the two charges is 2a, and this O is the midpoint, and from midpoint to the either of the charge the distance is A. So you can see in the diagram. Now P is a point at a distance r from the midpoint of the dipole on the axis. Look at the diagram. So this is a point P which is placed at a distance r from the midpoint of a dipole. This is the distance r. Now let us find the electric field intensity at point P due to both the charges, means plus q and minus q. So we have to find the electric field at point P due to both the charges plus q and minus q. First, electric field at a point P due to plus q charge which is placed at B, which is represented by E plus q, that is equal to 1 by 4 pi epsilon naught into q divided by bp square, means the distance between the positive charge to point P, this is bp square. Now the equation will become E plus q is equal to 1 by 4 pi epsilon naught into q divided by, what is this distance bp? The distance bp will be r minus a. Why it is r minus a? Because from B to P, from midpoint to P the distance is r, and from the midpoint to B the distance is a. Therefore the distance between B to P become r minus a. Therefore in the denominator we have r minus a the whole square. The direction of this electric field is along BP, because you know that the electric field at any point due to positive charge is directed away from the charge. So you can see in the diagram itself, E plus q is directed away from the charge. Now let us find the electric field due to negative charge minus q, which is placed at A. Now the equation is E minus q is equal to 1 by 4 pi epsilon naught into minus q divided by AP square, because the distance between the negative charge to point P is, this is AP square. And what is this AP? From the diagram you can see it is r plus a. Therefore in the denominator of this equation we have 1 by 4 pi epsilon naught into minus q divided by r plus a the whole square. And what is the direction of this electric field? This electric field is directed towards the charge, that is negative charge, because you know that electric field at any point due to a negative charge is always directed towards the charge. Therefore the direction is along PA. Now at point P there are two electric fields. One is due to positive charge and other one is due to negative charge, and this is the direction of electric field due to positive charge, and this is the direction of electric field due to negative charge. Now let us add them vectorially. Now you can see in the equation E is equal to EQ plus E minus Q. Now what is E plus Q? E plus Q is 1 by 4 pi epsilon naught into Q by r minus a the whole square, plus what is E minus Q? It is 1 by 4 pi epsilon naught into minus Q by r plus a the whole square. Correct? So we have substituted from these two equations. Yes. Now in both the terms q is common, therefore 1 by 4 pi epsilon naught into q, these two terms are common. Now let us take them out. Therefore, what remains in the first term is 1 by r minus a the whole square. And now this minus will be multiplied here. So this will be minus of 1 by r plus a the whole square. Now in the next step, let us take the LCM for this. LCM is r minus a the whole square into r plus a the whole square. And then in the numerator, we have r plus a whole square minus r minus a the whole square. Now the expansion of r plus a the whole square is r square plus a square plus 2ra minus r minus a the whole square. That will become r square plus a square minus 2ra. So in the numerator we have these terms and the remaining thing are one and the same. Now this r minus a the whole square can be written as r minus a into r minus a, and this r plus a the whole square is written as r plus a into r plus a. Now in the numerator, let us multiply this minus inside the bracket so that the equation will be minus r square minus a square plus 2ra. Now you can cancel this r square and minus r square, a square and minus a square, and what remains in the numerator is 4ra. Now in the denominator, r minus a into r plus a will be r square minus a square. So you can find two terms here, correct? R minus a into r plus a and one more r minus a into r plus a. Therefore in the denominator we have r square minus a square into r square minus a square. Now the denominator becomes r square minus a square the whole square. So finally, what is the equation? 1 by 4 pi epsilon naught into q. Inside the bracket we have 4ra divided by r square minus a square the whole square. Now let us take this q inside and write this 4ra as 2a into 2r. 4ra can be written as 2a into 2r and q is taken inside the bracket. Therefore this q into 2a, the term q into 2a will be a dipole moment. Look at this, P is equal to q into 2a. So P is a dipole moment. Therefore instead of this q into 2a in the previous equation, q into 2a is now written as vector P. Okay, vector P is a dipole moment. Therefore the equation becomes E is equal to 1 by 4 pi epsilon naught into P into 2r divided by r square minus a square the whole square. Now let us rearrange the equation. So E is equal to 1 by 4 pi epsilon naught into 2pr divided by r square minus a square the whole square, and the unit is Newton per coulomb. The unit of electric field is Newton per coulomb and the direction of this electric field is along BP. Okay, this is the derivation. And now let us consider the special case of this. If r is very much greater than a, means in the diagram you can see the distance r is larger than this distance a. So if it is very large, then what happens to the equation? Look at this. E is equal to 1 by 4 pi epsilon naught into 2pr divided by r square minus a square the whole square. So this a square term can be neglected, so that I have substituted this a square as 0 here. Therefore r square minus 0 the whole square. So in the denominator we have only r square the whole square, which means it is r power 4. So which will be cancelled with one term in the numerator r. Therefore what remains in the denominator is r cube. So the final equation becomes E is equal to 1 by 4 pi epsilon naught into 2p by r cube, and direction is along BP.